Hey guys, welcome to my channel. So today in this video we are going to cover the topics chemistry of stratospheric ozone. So the contents are definition, types, ozone formation, ozone depletion, causes of ozone layer depletion, ozone depleting substances or effects of ozone layer depletion and solutions to ozone depletion. First is stratospheric ozone. Stratospheric ozone is a naturally occurring gas that filters the sun's ultraviolet radiation. This is typically regarded as good ozone since it reduces the harmful effect of ultraviolet radiation. A diminished layer allows more radiation to reach the Earth's surface. Excessive exposure to UVB at the surface of Earth has been shown to cause harmful effects in plants and animals. The abundance of ozone in the stratosphere is in part determined by photochemical production of ozone and the abundances of reactive trace chemical species that catalyzes ozone removal processes. Significant stratospheric ozone losses was detected during the spring over Antarctica, now extended to all seasons and latitudes, polewards of 30° in both hemispheres. These are the layers of atmosphere, 5 layers of atmosphere: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Absorption of UVB by ozone in the stratosphere reduces the amount of UVB reaching the Earth's surface and also generates heat that plays a role in maintaining the temperature structure of the atmosphere. Ozone is a comparatively rare in atmosphere. There are only 3 molecules of ozone for every 10 million air molecules. 90% of the planet's ozone in the ozone layer, which exists in the lower level of stratosphere. The stratosphere is the region of atmosphere which exists between 10 to 15 kilometers above the Earth's surface. This is the Earth's surface. These are the different types of ultraviolet radiations: UVA, UVB, and UVC. This is the stratospheric ozone layer which protects the Earth's surface from the ultraviolet radiations. Solar wavelengths in the ultraviolet range are absorbed by a breakapart oxygen molecule. Some of the resulting unattached pair of oxygen atoms then recombine into triplets to form ozone layer. Ozone formula is O3. There are three oxygen molecules combined to form a molecule of ozone. A different range of wavelength of ultraviolet are strongly absorbed by ozone, which breaks down as a result and reform into molecular oxygen again. Ozone that occur in the troposphere is a much smaller proportion of the total planetary ozone and is regarded as bad ozone since it reacts easily with other molecules, making it highly toxic to living organisms. Tropospheric ozone is known to have negative impact on such things such as crop production, forest growth, human health. Tropospheric ozone is a key component of the photochemical smog which are observed in many cities. From 0 to 10 kilometer troposphere is present. In this layer, tropospheric ozone is present. Beyond this, stratosphere is present. In stratosphere, good ozone is present. Now we come to the part ozone formation and destruction. Ozone is produced by the combination of an oxygen atom with an oxygen molecule O2. The basic steps involved in the reaction are given below. In the above diagram, the oxygen atom is represented as dark blue circles. This reaction is written in chemical equation as O2 plus UV. O2 break down into two molecules of oxygen, and this O is combined with O2 molecule to form O3 molecule. O3 is the formula for ozone. What is ozone layer depletion? Ozone depletion is the thinning of the ozone layer present in the upper atmosphere. This happens when chlorine and bromine atoms in the atmosphere come in contact with ozone and destroy the ozone molecule. One chlorine can destroy 1 lakh molecule of ozone. It is destroyed more quickly than it is created. Some compounds release chlorine, bromine on exposure to high ultraviolet light, which then contribute to ozone layer depletion. Such compounds are ozone depleting substances. Ozone depleting substances that contain chlorine include chlorofluorocarbon, chlorotetrachloride, hydrochlorofluorocarbon, and methyl chloroform, whereas ozone depleting substances that contain bromine are methyl bromide and hydrobromofluorocarbon. Chlorofluorocarbon are the most abundant ozone depleting substances. It is only when the chlorine atom reacts with some other molecule it does not react with ozone. Now we come to ozone depletion. Ultraviolet radiation is also involved in destruction of ozone. Ultraviolet radiation strikes an ozone molecule splitting off an O atom. The free O atom colloids with O3 producing two oxygen molecules. The destruction occurred as O3 plus UV gives out O plus O2, and this O combines with O3 to release two molecules of oxygen. This is the net reaction involved in the ozone destruction. Ultraviolet radiation play a crucial role in the formation of destruction of ozone. Ultraviolet amounts are greatest in tropical region. Thus, it is not surprising that most of the destruction and production of ozone occur in the stratosphere. Causes of ozone layer depletion. The ozone layer depletion is the major concern, and it is associated with a number of factors that main cause responsible for the depletion of ozone layer are listed below. Chlorofluorocarbon, CFCs are the main causes of ozone layer depletion. These are released by solvent, sprays, aerosols, refrigerators, air conditioners. The molecule of chlorofluorocarbon in the atmosphere are broken down by the ultraviolet radiation and release chlorine atom. These atoms react with ozone and destroy it. Unregulated rock launches are also a main cause of ozone depletion. Researchers says that unregulated launches of rocket result in more depletion of ozone layer than the CFCs do. If not controlled, this might result in huge loss of ozone layer by 2050. Nitrogenous compounds are also a cause of ozone layer depletion. The nitrogenous compounds are NO2, nitridine, nitrogen dioxide, NO, are highly responsible for depletion of ozone layer. The natural cause of ozone layer has been found to be depleted by certain natural processes such as sunspot and stratospheric wind, but it does not cause more than 1 to 2% of the ozone layer depletion. The volcanic eruption are also responsible for the depletion of ozone layer. Now, effects of ozone layer depletion. The depletion of ozone layer has harmful effect on environment. Let us see the major effect of ozone layer depletion on man and environment. First is on human health. The human will directly exposed to the harmful ultraviolet radiation of the sun due to depletion of ozone layer. This might cause serious health issues like skin diseases, cancer, sunburns, cataract, quick aging, and weak immune system. On animals, direct exposure to UV radiation leads to skin and eye cancer in animals. Effects on environment: strong UV radiations may lead to minimum growth, flowering, and photosynthesis in plants. The forest also have to bear the harmful effects of ultraviolet radiations. Effects on marine life: planktons are greatly affected by the exposure to harmful ultraviolet rays. These are higher in aquatic food chain. If the planktons are destroyed, the organisms present in the food chain are also affected. Solutions to ozone layer depletion. Depletion of ozone layer is a serious issue, and various programs have been launched by the government of various countries to prevent it. However, some steps should be taken at the individual level as well to prevent the ozone layer depletion. Following are some points that would help in preventing the problem at global level. Avoid using ozone depleting substances. The reduce use of ozone depleting substances. Example: avoid the use of CFCs in refrigerators and air conditioner, replacing the halogens based fire extinguishers, etc. Minimize the use of vehicles. The vehicles emits a large amount of greenhouse gases that leads to warming as well as ozone depletion. Therefore, the use of vehicles should be minimized as much as possible. Next is use of eco-friendly cleaning products. Most of the cleaning products have chlorine, bromine releasing chemicals that find a way into the atmosphere and affect ozone layer. These should be substituted with natural products to protect the environment. Use of nitrous oxide should be prohibited. The government should take action and prohibit the use of harmful nitrous oxide that is adversely affect the ozone layer. People should be made aware of harmful effects of nitrous oxide and the products emitted the gas so that its use is minimized at individual level as well. Ozone depleting substances are CFCs, halogens, carbon tetrachloride, methyl chloroform, hydrofluorocarbon. The sources of CFCs are refrigerator, air conditioner, solvents, dry cleaning agents, etc. And halogens are fire extinguishers. For carbon tetrachloride are fire extinguishers, solvents. Methyl chloroform sources are adhesive and aerosols, and hydrofluorocarbon fire extinguishers, air conditioners, and solvents. Ozone depleting substances are the substances such as CFCs, halogens, carbon tetrachloride, hydrofluorocarbon, etc. that are responsible for the depletion of ozone layer. Thank you for watching. Hope you like the video. Thank you so much.